Today we're going to look at the applications of differentiation. We know that with differentiation we have a strong tool which will help us to find the gradient of the tangent to a curve. In this example we need to find the equation of the tangent. Now our strategy for finding the gradient of the tangent is to look for the derivative of the function. So we have the function y equals sine x. We know that the derivative of this function, dy by dx, is equal to cos x. To find the equation of the tangent at the point pi 0, we need to substitute the point pi 0 into the derivative function. So we land up with dy by dx is equal to cos pi. This means that the gradient of the tangent is equal to cos pi. Let's think about the cos curve for a moment. When I look at the shape of the cos curve, I know that the curve cos pi has a period of 2 pi, pi on 2, and this is the point 3 pi on 2. So if I am looking for the place where the gradient is equal to cos pi, I can plot that to be a value of -1. The gradient of this tangent then is -1. We look at the general form of a straight line graph, y equals mx plus c. We have just discovered that the gradient is -1, so when we substitute we get y equals -x plus c. We know that the point pi 0 falls on the line, so we substitute this point into our equation to solve for c. So, considering my equation y equals -x plus c, I am going to substitute the point pi 0 into this equation. That gives me 0 is equal to minus x, which is pi, plus c. So c is equal to pi. Therefore, my equation is y equals -x plus pi. Let's look at another example. In this case, the population of a colony of frogs rises and falls according to the breeding season. The population can be modelled by the equation p of t equals 100 sine pi t over 2 plus 500, where t is the number of months since the beginning of the year. Here we have to find the population at the beginning of the year. So the population at the beginning of the year implies that the time is equal to 0. So no months have passed. So p of 0 will be 100 sine pi times 0 over 2 plus 500. Simplifying gives me 100 sine 0 plus 500. Now we know that the sine of 0 is equal to 0. Therefore 100 sine 0 is 0. So my answer is 500. There would be 500 frogs at the start of the year. In thinking about these frogs, I think it's important that we actually take a sketch of the function so we can see where is the first time where the population is greatest. It's a periodic function, so there's more than one time where the population has a maximum. Let's have a look at this function. It's a sine function, so we can see that it starts at 0, reaches a maximum value, passes through the 0 point again, and reaches a minimum value. The place that we are looking for is the first time at which the population is greatest. In order to consider this, we're really looking at this particular point on the curve. So where is this point found? Well, in considering my period of the sine curve, I know that this is the point pi on 2. So we are really looking for the derivative when x is pi on 2. Let's differentiate this function. The derivative p dash t is going to be equal to 100 times pi over 2, which is the derivative of pi t over 2. Derivative of sine is cos pi t over 2 plus 500, which is a constant and falls away. That gives me 100 pi over 2 cos pi t over 2. Well, 100 over 2 is 50. So we have a derivative of 50 pi cos pi t over 2. Now, we know that our graph has a maximum when the derivative is equal to 0. So we take our derivative, 50 pi cos pi t over 2, and make it equal to 0. In simplifying this equation, we divide by 50 pi, and we get cos of pi t over 2 equals 0. Now, where is the cos graph equal to 0? We need to have a look at the cos graph to see when the cos graph is equal to 0. When we look at our cos graph, we can see that it is equal to 0 at these two places. Now, we are looking for the first time at which the population is the greatest, so we are considering the value of pi over 2. We can therefore say that the first time at which the population is the greatest, pi t over 2 is equal to pi over 2. When I simplify this equation, multiply both sides by 2 over pi, and I get t is equal to 1. In the context of the problem, after 1 month, the population has a maximum value.